In this lesson, we're going to be solving this problem. This problem is under a projectile motion. So here, the problem, it reads as follows. A cannon situated on the building 40 meter high fire a shell horizontally at a velocity of 280 meter per second. Calculate the time taken until the shell hits the ground and the horizontal displacement of the shell. Here we're given the height here, which is this 40 meters. Then we're given the velocity here of the shell that is fired horizontally. So let me draw this to illustrate more. It is like this. Then this cannon, it's here. It fires a shell. Roll to here. Then let us say here it's A, here it's B, here it's C. Then here the velocity, say it is V. It's a horizontal velocity. The initial horizontal velocity is 280 meters per second. Then because it's a horizontal, that means the initial y velocity for a vertical is equal to 0. Then it's 40 meters high. They say you must find the time taken until the shell hits the ground. That means they are looking for TAC from here until here. And you must remember G here is positive because this shell is not against the gravity, but it's going towards the gravity. We're looking for a time it takes from A to C. Then we're looking for this distance. So it's a distance BC. We have to calculate time because if you are looking at this is a horizontally. To find this horizontal distance from here to here, we have to apply this equation of motion. It is SBC is equal to initial velocity times the time it takes A to C. Then you plus half GT squared. Then because we are dealing with horizontal, that means G is 0. That the whole this term is 0. Then we're left with this distance we're looking for and this velocity, horizontal velocity initial, then the time it takes from A to C. We do have this. It is this velocity, but we don't have this. So to find this distance, we have to find the time. That's what they are looking for in question number 1. So let us find time. To find time, we'll apply one of equation of motion, but for the vertical, it will be a distance, this distance from this one to here. It is distance A, B is equal to the vertical initial velocity times the time it takes A to C plus half GT squared AC. So here, this term, because this vertical initial velocity, this one is 0. That means this term is equal to 0, whole of this term. Then we're left with this term and this one. Let us write it down here. It is the distance AB is equal to, then we're left with this half GT squared, that is AC. Then here we do have this one, the distance AB. We do have that distance. Then we'll write it here. 40 is equal to half GT squared AC. Then from here we have to make this a subject of the formula. Then we times this 40 by this 2, then we divide by this G. It's gonna be T squared. This is AC is equal to 40 times 2, this 2 then divide by this g like this. Then here it is 80 divided by 9.81. Then to remove that squared here, this one, we have to put the square root both side. It's gonna be TAC when you put a square root both side like this. Then this gonna be left with this time A to C is equal to this square root 80 divided by 9.81. Then when you proceed here, it's gonna give you 2.9 seconds. That's the time it takes from A to C. The time it takes from A to C, it is TAC is equal to 2.9 seconds. Now we've got the time it takes. Now let us come back to this formula. Here it is here. Let's write it here on the bottom clearly. It is S distance BC is equal to a horizontal initial velocity times the time it takes from A to C. Now we've got this one. We have this one we're given. Let us substitute. This is 280 meters per second times the time that we've got now. This one, it is 2.9 seconds. Then this, it's gonna give you a 799.6 meters like this. That the distance for this part. The distance is for that part. Then that means you've got the answer that they were looking for. Here the time it take, it is 2.9. It is 2.9 seconds. Here the distance, it is 700. It is 799.6 meters. It is how you calculate such question.